Hello everyone, welcome to Code Line. Today we are going to learn about one of the most famous recursive problems in data structures and algorithms, the Tower of Hanoi. So let's go through with my slides. What is Tower of Hanoi? Tower of Hanoi is a puzzle used to teach recursion and problem solving. It has 3 rods and several disks of different sizes. These are the 3 important rules we must always follow. Rule number 1, move only one disk at a time. Rule number 2, only the top disk can be moved. Rule number 3, a larger disk cannot be placed on a smaller disk. Now, let's understand the main rules of the Tower of Hanoi puzzle. These rules may look simple at first, but they are what make the puzzle challenging and interesting. The first rule is that only one disk can be moved at a time. This means we cannot pick up multiple disks together and move them as a group. Every move must be done step by step and one disk after another. This rule prevents shortcuts and makes the puzzle more systematic. Because of this, players need to think carefully before making each move. Even a simple mistake can affect the next step, so planning becomes very important. This rule also helps improve logical thinking and patience because every move matters. The second rule is that only the top disk of a stack can be moved. If a larger disk is under a smaller disk, we cannot directly take it. First, we must move the smaller disk away carefully. This keeps the stack order correct and organized throughout the puzzle. Because of this rule, players must think about the correct sequence of moves instead of randomly moving disks. It teaches us how to solve problems step by step and how one action can affect the next action. The third rule is that a larger disk cannot never be placed on the top of a smaller disk. For example, if a small disk is already on a rod, we cannot place a bigger disk over it. This rule avoids invalid arrangements and creates the main challenge of the puzzle. Players must always pay attention to the size and the disk before making a move. Because of this restriction, the puzzle becomes more difficult and requires strategic thinking and careful planning. So, even though these rules are very simple, together they create a surprisingly complex puzzle. The Tower of Hanoi is a great example of how simple rules can be developed logical thinking, problem solving, and recursive thinking in computer science and mathematics. This is why this puzzle is still widely used for learning algorithms and programming concepts today. So, let's see what recursion is. Recursion means solving a large problem using smaller versions of the same problem. So, here are some key facts. Recursion repeats the same steps. It makes complex problems easier. And also it is used in many programming algorithms. Now let's look at some real-life uses of recursion. Recursion is not only used in puzzles like the Tower of Hanoi, but also in many real computer science applications. One common example is file systems. When we open folders inside other folders on a computer, the system often uses recursion to explore all the files and directories. Recursion is also used in searching algorithms to find information quickly and efficiently. In artificial intelligence, recursion helps computers process complex decisions and patterns step by step. Games also use recursion for solving paths, creating strategies, and handling repeated actions. Another important use is in tree structures, which are widely used in data structures and databases. Recursion helps to move through branches and nodes in an organized way. So, recursion is a very powerful concept that is used in many real world technologies and applications. So, we can see the same process repeats again and again. That repeating process is called recursion. Now, let's understand why recursion is used in the Tower of Hanoi problem. Before moving the largest disk, we first need to move the smaller disks out of the way. That is why we move n-1 disks first. The largest disk is blocked, so the smaller disks must be moved to another lot before we can continue. After moving the largest disk, we again move the smaller disks back on top of it. This creates the same process again and again. For an example, solving the problem for 2 disks follows almost the same pattern as solving it for 3 disks or even more disks. Only the number of steps increases. That repeating process is called recursion. So, the same logic repeats for every number of disks, and that is what makes recursion such an important concept in the Tower of Hanoi problem. So, we can see the same process repeats again and again. That repeating process is called recursion. Now, let's see how Hanoi Tower works. Can you move an entire tower using only one disk at a time without ever placing a big disk on a small one? That's the famous Tower of Hanoi puzzle. Let me remind you the rules again in a different way. First, you only have one hand, so you can move only one disk at a time. Then, you only pick the top disk. And the third rule, big disks are heavy. They will crush smaller disks. Imagine you want to take the biggest book from the bottom. First, you must move all smaller books away. After moving the biggest one, you place the smaller books back again. Tower of Hanoi works exactly like that. So, let's see how the disks are going to move. Move disk 1 from A to C. Then, move disk 2 from A to B. Then move disk 1 from C to B. Then move disk 3 from A to C. Then move disk 1 from B to A. We move disk 2 from B to C. And finally, move disk 1 from A to C. This is an example how recursion works in 3 disks. Notice how smaller disks are moved first to free the larger disk. So, this is the formula which is used to find the number of moves. This formula helps us calculate the minimum number of moves required. As you can see, the formula is 2 to the power n minus 1. Here the letter n represents the number of disks. As for example, if we take 3 disks, so if we take 2 to the power 3 minus 1, which equals to 7, is the answer. So, what are the importances of Hanoi Tower? This puzzle is important because it teaches one of the main concepts in programming, recursion. So, Tower of Hanoi helps us learn recursion, algorithm thinking, logical problem solving, and breaking problems into smaller tasks. It also improves important skills such as analytical thinking, planning skills, algorithm understanding, and recursive thinking. While solving the puzzle, players must carefully plan each move and think ahead before making decisions. This develops step-by-step thinking and improves problem-solving ability. The Tower of Hanoi also has a strong connection to real programming. Many programming problems use recursion in a similar way. For example, recursion is commonly used in searching algorithms, sorting algorithms, and tree traversal in data structures. So, this puzzle is not only a game or a mathematical challenge but also an important learning tool in computer science and programming. So, Tower of Hanoi is a simple but powerful puzzle used to understand recursion in data structures and algorithms. Here is a small summary of this. Thank you for watching. Subscribe Codeline for more data structures and algorithm tutorials.